Okay, today we are going to do like a second geometry review day. You should have already checked your answers on review day 1 over area, surface area, and volume of prisms. So we're going to do a little bit on circles and cylinders because you are also going to need this for the next part of our chapter. So let's review some basics about circles in this kind of vocabulary section towards the top. A diameter is the distance across a circle. Sorry about that. That is a straight line. So when we draw that in our diagram, we're going to take that all the way across. Oop, that is a little big. Let's just go with this straight line. We're going to go straight across the circle. Now, just to show this in reference with other colors, diameters can go through that way. We could draw another diameter going through that way. The main point of it all is that it has to go through the point that is the center of the circle. All right, moving on to the radius. Our radius is halfway across the circle. And it's touching the center and one side. So if we draw a center point on this diagram, do the best I can from the center, and then we can draw a radius from here. We could draw a radius from here. Anything that is halfway across touching the center and one side. So there's 3 radii in that diagram. Let's talk about our circumference. So circumference is the distance around a circle. Let's try that highlight tool again. So we're going to go all the way around this circle is your circumference. So let's write that definition in. Circumference is the distance around the circle. We could also refer to this as the perimeter of the circle. Next up is area. When we talk about area of a circle, we are going to talk about the inside space. So if we go around the outside, we are also going to fill that space in if it'll let me. Let's try again. Let's just start over. So we're going to fill all of that space in on our circle, and this is the area. So area is the inside space of the circle. And the last thing as far as definitions go is the 2 formulas that we're going to use in the following examples. So there are 2 circumference formulas, and they are used based upon whether you're given the radius or the diameter. So the first formula is going to be C is equal to pi times diameter. And the second formula is going to be circumference, or C is 2 pi r. So in both of these cases, pi, we are going to use 3.14. You may see a pi button on your calculator if you have a more advanced calculator. I want you to go ahead and type in 3.14 when you're calculating. And then we obviously know the D stands for diameter, and the R stands for radius. So you have to be really careful and look at those when you are calculating. And then the second or third formula that we're going to use, there's only one for area, and that is area equals, or A equals, pi r squared. So essentially pi times radius, but we abbreviate it with that r squared. Okay, so let's take a look at some examples together. These are pretty simple numbers just to show you how to use those three formulas. So the first set is find the circumference of the circle below using 3.14 for pi and round your answer to the nearest tenth. So we're going to set this up. We're finding circumference, and I can see right here that half the distance across the circle is the radius, so I'm going to use 2 pi r. So 2 times 3.14 times the radius of 2, so I'm going to just do 2 times 2 in my head, calculate 4 times 3.14, and I get 12.56, but this tells me to the nearest tenth, so I'm going to go 12.6 inches. Looking at example 2, I can see that this has a diameter, so circumference equals pi times diameter. Pi again is 3.14. Our diameter is 16, so this is just direct multiplication. I get 50.24. Rounded to the nearest tenth is 50.2 meters. Moving over to the 2 area examples, still going to use 3.14 for pi, and we're still going to round to the nearest tenth. There's only one formula here for these, so area equals pi r squared. So I'm just going to fill in 3.14. The radius is here on example 3. So I'm going to do 5 times 5. I know 5 times 5 is 25. I use my calculator and get 78.5. No rounding needed. And this is going to be feet squared because it's area. Going to example number 4. Area equals pi r squared. 3.14, and now this time I notice I have the diameter, so I need to break 17 into a radius, so I'm going to divide it by 2, and 17 divided by 2 is 8.5, so that's my radius, and I'm going to calculate that all with my calculator. I get 226.865. So I'm going to go to 26.9 centimeters squared. All right, that is kind of the basics of circles. And we're going to move on pretty quickly here. And we're going to talk about surface area and volume. I actually think surface area and volume of cylinders is a little easier than prisms. The two formulas are actually a lot nicer. Surface area is still a little more complex, so let's write those in. So this stands for surface area equals 2 times pi times radius times height plus second part of the formula, 2 times pi times the radius times the radius. Let's go over to the volume formula. This stands for volume equals pi times the radius times the height. Let's try some calculating with these two examples. Starting with the surface area, I'm just going to write my 2 in, my 3.14. I notice my radius is 2, my height is 6. Second half, 2 times 3.14 again. And my radius is 2, and I'm going to multiply it by itself. Quite honestly, this is just a lot of calculator work. So I know 2 times 2 is 4, and 4 times 6 is 24. And then I'm just going to take that 24 times 3.14. Next one, I know 2 times 2 is 4, 4 times 2 is 8. And we get 25.12. And then I'm going to simply just put them together. And this is still area, so meters squared. Going over to volume, got that pi. The radius is still 2, so 2 times 2, and the height is 6. Again, 2 times 2 is 4, 4 times 6 is 24, and 24 times 3.14 is 75.36. And that's meters cubed because we are filling that up. The only difference on example number 2 is that you have that cylinder laying on its side, and I noticed that the line going through the center is the diameter, and I mostly need a radius for these type of calculations. So I just have to be pretty careful. So I still have 2 and 3.14. And then I need, looking at my formula, the radius and the height. The radius is 7, and although it's laying down, the height is 26. So just be really careful with those. Again, 2 times pi, and then again our radius is 7 squared, or 7 times 7. A little bit bigger numbers here, so I'm going to rely on my calculator a little more. I got 14 times 26 times 3.14. And then 49 times 2 times 3.14. Add those together, get 1,450.68 feet squared. Let's go over to the volume. Got pi, radius times radius, and the height of 26. So 49 times 26 times 3.14. 4,036 feet, and this is cubed. There's a few questions at the bottom here that I want you to consider, and I'm going to talk about them by drawing some pictures. When we talk about the lateral area of a cylinder, we're simply talking about, and I'll use this diagram up at the top, I'm simply talking about the rectangle that kind of surrounds it. So I'm going to draw it out here so you can see it. We're talking about that. Like if you think of a soup can, if you cut the label off, the lateral area is the label that surrounds the soup can from top to bottom around the cylinder. If you wanted to find the surface area of only that lateral area or the lateral face, which part of the formula would you use? So you have 2 sides to this formula. If you look back up top, this 2 pi r squared, that looks a lot like the area of a circle, except for on a cylinder, we have 2 circles. So when we are considering only this rectangular face, we only have to consider the lateral face, or the lateral area of the rectangle in that cylinder. We don't have to consider the circle on the top and the circle on the bottom. So when I'm considering doing that surface area, I only have to consider 2 pi r h. If I want to find the surface of only the circle bases, which is part of the formula, you would use that last half. There's 2 circles. Pi r squared is area. So 2 times pi r squared is just the 2 circular bases on the top and the bottom. If I wanted to find only the surface area of the lateral area in one circle, you would literally say, well, here's the lateral area. And then I only need 1 circle, so instead of multiplying pi r squared by 2, I would just say plus pi r squared, or that 1 circle, whether it be the top or the bottom. So go ahead and try to find the lateral area of the 2 cylinders above. I want you to think about that, and we will talk about that together. So remember, lateral area is this part of the formula. After you try that lateral area for cylinder 1 and cylinder 2, you're going to go down and do the practice for circles and cylinders.